Question 16. Find the number of arrangements of the word independence. In how many arrangement in first part do the first word start with P? Okay, so we have this word independence, I-N-D-E-P-E-N-D-E-N-C-E. So this contains 3N, 2 D's and 4 E's. Okay. So this is how the letters are being repeated. Now we have to find the total number of arrangements. So the total number of arrangement of this word independence is equal to by applying the formula n factorial upon p1 factorial into p2 factorial into p3 factorial. Okay, we are going to get this as 12 factorial upon 3 factorial into 2 factorial into 4 factorial. Okay, so this will be equal to 12 factorial divided by 3 factorial divided by 2 factorial divided by 4 factorial. So this will be equal to 3200 1663200 1,663,200. Okay, in second part we have to, actually this was not the first part is now beginning. So in how many of these words start with P? Okay, so we have to now find the number of words starting with P. So if the words start with P, then the first place is fixed. We have now 11 places, and in 11 places we have to arrange these 11 letters. Okay, excluding P. P is not to be included. So this will be equal to 11 factorial upon 3 factorial into 2 factorial into 4 factorial. So this will be same as 1663200 divided by 12, because there is only a difference of 12. So this will be equal to 1, 3 carry, 12 is a 36, 12 is a 96, and 7 carry, so 12 6 are 72. So this will be equal to 138,600. Okay. In third part, in how many of this vowel occur together? Okay. So this word independent has two vowels, I and E. E is repeated 4 times and I comes only 1. And 7 letters are there, in which we have 3 N's and 2 D. This is the only repetition, and rest letters are different. Okay. So what I'm going to do, I'm going to assume that this is equal to alpha. All these 5 vowels as equal to alpha. Okay. So now we have to arrange these 5 this alpha with these 7 letters. So this will be same as arranging 8 objects. Okay. So the number of ways of arranging 8 objects is equal to 8 factorial upon 2 factorial into 3 factorial. But alpha is equivalent to these 5 letters, and they can arrange themselves in how many ways? 5 factorial upon 4 factorial ways. Okay. So the total number of ways will be equal to the product of arranging 8 objects into the number of ways in which vowels can arrange themselves. Okay. So this will be equal to 8 factorial upon 2 factorial into 3 factorial into 5. Okay. Now we are going to calculate its value. This will be equal to 8 factorial into 5 divided by 12 divided by 12. So this will be equal to 16800. 16800. Okay. In third part, we have to calculate the number of ways in which no vowels occur together. So we have calculated the ways in which vowels are occurring together. We have calculated the ways in we have calculated the total number of ways. So the total number of ways which we had calculated gives us all the possible ways in which vowel occur together and not occur together. Okay, if we subtract from it the number of ways in which all the vowels occur together, okay, that is from the total possible ways, if we subtract 16800, so we are left with the total number of ways in which the vowels never occur together, and this will be equal to 4. This will be equal to 6, 4, 1, 6, 1,646,400. Okay. And in fourth part, what we have to do, in how many ways do the words begin with I and end with P? The word is going to begin with I and it is going to end with P. So in between there will be how many letters? There will be 10 letters. Okay. And these 10 letters are going to contain 4 E's. Okay. 3 N. Okay. And 2 D's. So this will be equal to how much? 10 factorial upon 4 factorial into 3 factorial into 2 factorial. Okay. 10 factorial divided by 4 factorial divided by 6 divided by 12 divided by 12. 3 factorial into 2 factorial is equal to 12. So we get this as how many ways? 12600 ways. Okay. So the number of ways in which the word begins with I and ends with P is equal to 12,600. Okay.